Hello, Tech Buddies. Hope you guys are doing well. A very warm welcome to my YouTube channel, High Tech Masterminds. In our videos, we will discuss and understand some basic technical concepts and deep dive in further, as and when required. I'm Hitesh, your technical buddy in this journey. Alright, let's get started. This is a very first video for the series, so I have kept it really short and pretty much basic. I'm going to prepare a series of videos for those who are willing to start their career as a system admin. This series will definitely help you in many aspects in terms of building your career as a system admin. In today's video, I'm going to talk about an overview of data centers followed by Linux. So, welcome to Linux, a journey beginners to advance. Today is day 1, and first we will see what data centers are, what are the major units in data center, along with some data center operations. So let's get started. Very first question that comes in our mind is, what is a data center? To answer that, we can say data center is simply a place where companies will keep their huge servers and storage connected to each other for compute power. Let's assume you want to set up a data center. The very first thing you need is a power unit, from where the power will be supplied to the whole data center. Okay. Next thing, we need servers to process the application on them. Okay. Now, if we have servers which are gonna store huge amount of data, then we need extra storage space as well, called SAN or NAS. For now, you can ignore these terms as we will cover them up some part later. As we have to reach to the servers over network, we need network switches and cables connected to the server. Next, we will understand how these components are connected to each other. Practically, there are so many components which are required to build a DC. However, just to start with, you can configure storage boxes first, which are then connected to SAN switches. In this diagram, we have mentioned Cisco MDS 9100 as an example. We have connected 3 storage boxes to 2 SAN switches with fiber optic cables to achieve multipathing. Don't worry about this for now. We will discuss multipath concept later in the series. The SAN switches will later connect to servers, and these servers are internally connected via Ethernet cables. Nowadays, we have more faster cables available along with faster network cards such as RDMA, remote direct access memory cards. It's been over a decade now. These cards and these cables are available. Furthermore, to add another level of security, most of the organizations will configure the external firewalls through which outside network can be accessible with a lesser risk. Now, if you enter a data center, it will be really cool. I mean, the temperature inside, it is really cool. It is really low. Not to let the systems overheated. These beasts are power hungry and gets heated easily if not cooling system is installed, which will damage the internal circuits and the servers might get hurt too. Here is an image of typical data center which has so many cables connected to the servers, to switches, and so on. People work in these data centers has many roles and responsibilities. A few of them are building physical servers, setting up a proper network connections, performing hardware replacements and upgrades. Then, if something has to be replaced by the vendor, they have to arrange the visit as well. So these are some basic day-to-day activities happening in a data center. As now we know what data centers are, let's move forward with Linux operating system. Again, what is Linux? In simple terms, Linux is a Unix-based operating system which was first developed by AT&T in late 60s. It's one of the open source and very flexible operating system available in the market. There are multiple vendors who have developed their own flavors out of it. Some of them are well known as Red Hat, SUSE Linux, Fedora, and many more. Mainly, Linux is more powerful as a server-based operating system. Reason, it has really great offering on tons of features, out of which we have listed a few as below. The very first one is open source. This means it is freely available to anyone and everyone who wish to install Linux in their system. Linux is highly secure. Even though it's a free software, Linux is highly secure as Linux has its own security features such as SE-Linux, IP tables, firewalls, or file permissions. The Linux is a multi-user and multitasking OS. Now, every operating system these days is a multi-user and multitasking, which means there can be multiple users working on same system and can have their own tasks or applications running at the same time. Linux is more stable. Linux is one of the most stable operating system available in these days. There are pretty less chances that system is getting panicked or rebooted or crashed automatically. High performance. The CPU and memory scheduling in Linux is very good. Hence, the system performance is really high. Very flexible. As the OS is open source, users can have their customization done as per their requirement. Unlike Windows, Windows is not open source, so you cannot do more modifications to the OS itself. Next, we will understand Linux architecture. In Linux architecture, we will discuss and understand what are the building blocks of Linux as an OS. Primarily, Linux OS consists of kernel modules, kernel, system libraries, shell, system software, and user or application processes. Let's discuss them one by one. The very first one is kernel module. Every hardware understands its own language. To let kernel interact with these hardwares, kernel modules will be written by the hardware vendors or OS developers itself. These will be installed to recognize hardwares which are attached to the server and work with them. The second one is kernel. Kernel is heart of your entire system. This will be directly operating with hardware, and it will also be providing services to users or an application. Third one is system libraries. To communicate with kernel, we need intermediator, which are these system libraries. These will help users or applications interact with kernel. Fourth one is shell. These are terminals which are provided to users and applications to perform their task. With the help of different shells or terminals, you can execute commands or run any application on it. For example, shell sh, Pony again shell bash, csh, tsh, etc. etc. The final one is system softwares, user or an application process. This is the topmost layer in the architecture, where users are permitted to work. In next diagram, we can see everything below system call interface is kernel space, including system calls. Here, all the system activities will be taking place. And above that, it's a user space, where users are allowed to work. That's it for this lecture. We will meet in next video soon. Thank you for watching and have a great day. Bye for now.